All right, let's just test this. Testing, testing, 1, 2, 3. Okay, cool. I wish it wasn't so delayed, but that's fine. Great. We're live. I'm going to take my headphones off now. All right, before we get started, I just want to talk a little bit about something. Do I want to talk about it now? Maybe. Yeah, I guess. Well, I don't know if you watched the previous stream. If you did, then thanks for tuning in. But at the end, I said it was a failure. Now, the stream is not a failure because I did the stream. It's just that we didn't hit the target that we set. That's okay. And I was thinking, sometimes I think, man, when you stream and then you can't figure things out and you look stupid, what does that look like? And I think that's a bad thing to focus on, because if you're worried about looking stupid, then you'll never do anything in your life because you'll just be too scared, basically. So, yeah. I don't really know who needs to hear that, but don't be afraid of looking dumb. I think it's important. I mean, it's hard not to be afraid of looking dumb. I think we're sort of conditioned by societal norms to not want to look stupid. But if you don't try anything, you never learn anything. I mean, I guess you don't have to try it publicly, but I don't know. I feel like it does add something substantial when you're doing something in front of other people. Anyway, that's all I wanted to say for right now. But as what we're doing pertains to yesterday, that was not the right sentence. As for what we were looking at yesterday, it was about the shadow space in x64, and I was having some brain farts and I couldn't figure it out, and there was some construction happening and etc. So give myself a bit of leeway. Also, I just think the explanations are really confusing when I look at them. So I'm still not 100% comfortable with this right now, so we're going to just do some exploration. But I think if someone just explained it like, oh, you need to reserve some space on the stack because the Windows calling convention or API is going to put the variables that you pass in into that space. So you got to reserve them up front. All right, that's what this is for, the 32 bytes. And then there's also the alignment problem. So you've got to align the stack to be on 16 byte boundaries. So yeah, what is this program? So this program calls do something. Okay. And then moves into ECX to number 42 and then calls exit process. So this is probably just gonna work. Also, I haven't figured out a good way to look at the registers and stuff on Windows. I guess I could use RADDBG, maybe. Let's have a look. So, just gotta, what's the entry point? Start. And we're linking test.obj and we need kernel 32, yeah. Subsystem must be defined, okay. Fine. Okay. We've got test.exe, and then we can echo error level, so I've got 42, that's correct. So let's see if we can just break this. So if we don't align the stack, we don't subtract the 32 bytes plus the 8 in this case. We don't even call this procedure here. I should probably make this into a script. Do I have one? Nope. I'll make it, I guess, just run.bat. So we're going to grab this, make a little script here. Grab this one. All right, so we got linking, and then we got to run it. So that'll just be test. Maybe like this. I'll just add the executable, even though we don't need that. And then error level is what we want to echo. Okay. Now if I type run, te no such file or directory. What? Oh, it broke to the new line. There we go. Cool. Now I want to look at the registers and stuff while we do this. So we've got a test exe. Can I edit this? Can't remember how to edit these. Here we go. NASM? No, that's the wrong directory. Test2. That one. Test. All right. Great. So we'll just step into here. Okay, move into ECX 0x2a. That's 42, right? Okay. I haven't done much assembly. See, you know, I made an assembly language for my game, right? But because I made the virtual machine, I could just make the virtual machine work how I wanted. And so it wasn't confusing at all. All right, let's see if we can get something in here, I guess. What can we put in here? What is there? Watch registers. Okay, that's what I was looking for. How do I make it? Okay, there we go. All right, so what are we looking for exactly? There's a lot of registers here. Man, we have a lot of registers. So my game has 4 registers and 4 cores per 4 cores and 4 registers per core. So it's really simple. Oh, I guess there's also a test register. So 5 registers. Oh, and there's a CID. That's not really a register. Anyway. R8, R9. What am I looking for? ECX, so RAX. No, RCX, sorry. Okay, so if we step here, okay, we've got the value 0x2a, that's cool. Then we step in. Okay. So adding to BH, the value in BH. Okay. Okay, now it's allocating some stack space, right? And then calling whatever this is, which is now pushing something. Okay. Okay, more stack space, moving into EBX, the value that's in ECX, which is what? Okay, 42. All right. Right. There's a lot of stuff going on here, and I guess this is inside exit process. Calling multiple functions. Guess we go to here. Doing some tests, loading into RDX some pointer, I guess. Okay. Int C, no, what's inc? Oh, increment ECX. What's even in there? 0. Okay. And then jumping. I don't even know what this is doing, obviously. I mean, I can see the instructions, but I have no context for what's going on exactly. Moving 0x1 into RCX. Returning. So we've got another function call. I'm not going to go into all these function calls, I don't think. Okay, so we got an error here because we tried to move a what is that? Double quad? No, that's not right. I don't know what DQA is. What's move DQA? Move aligned double quad word. Okay. So XMM registers. That's usually where you put floating point numbers, but 128. All right. Well, anyway, this has failed. And there's nothing in here. All right. Well, I don't exactly understand why that failed, which is kind of a problem. I know how to fix it now, I think, which is to look at this. So we got allocate or reserve space for 4 variables on the stack before we call exit process, because it's not a leaf function. So it calls other functions inside of itself. So we've got to do that first. So why is my indentation all messed up? Gonna need to fix my NeoVim configuration, I guess. Because this is a tab. Yeah, it was indented by like 8 spaces or something. Okay. In this case... Oh, sorry, I didn't see chat. I had the wrong window open. Let me see. So Abel says, true, plus you've been in this industry a lot longer than most average people, so why listen to people that don't know what they're saying, that don't know most of the things that you know? Yeah, I mean, that's kind of true. I mean, I only really started game programming in 2019, so it's not, I mean, I guess that's 7 years now, almost 7 years ago. Before that, I was in front-end web, and I didn't feel like I knew how to program a computer when I went from front-end into, like, C, for example. Christopher, hey, how you going? Thanks for saying hi. And Chief, how you doing? Welcome in. Falcon Lang released before Jai? I don't think so. I think Jai's coming out soon. My goal is to have a working version of this language by the end of 2027. And I'm going to port, I don't even know if I talked about this online at all, but I have a Frostbite 3 style renderer that I made in Vulkan for my game, which has a 3D like overworld part. So there's like a 2D puzzle part, which I've released on Steam, which is getting a facelift. And then for the puzzle selection, there's like a 3D scene. The reason I want that is because there's narrative in the game where you're sort of doing these jobs and the city that you're working in is falling apart. You're doing these jobs fixing microcontrollers, but just because of, you know, whatever's going on in the background story, there's stuff happening in the game. So I want you to be able to see fires and riots and, you know, if it's raining, that'd be cool or whatever, just to give you a bit more flavor rather than just right now there's just sort of hints in the text and there's like a news bulletin email you get or something like that that tells you what's going on. I want it to be a little bit more high quality. So yeah, I've been working on that. So I want to get that ported and working by the end of this year in this language. So we'll see. That's the plan. But I have to figure out first x64 ABI conventions. And then hopefully once I figure that out, it'll be a bit easier. Any particular features I want to implement? Yeah, I covered a few of them in an earlier stream, but do I have a language spec I want to aim for? Do I plan to release a language? Oh, sorry, there's a lot of questions right now. Okay, let me go from top to bottom. Are there any features, particular features I want to implement? Yes. I'll spoil that now. What the main thing that I want to test is. So I'm not 100% sure on all of the technical details here, so I might say some things that are incorrect. Just correct me in the comments or in chat if I say something that's bad or incorrect. However, I believe that there are optimizations you can make when, for example, reading and writing memory that are what they call, I think it's non-aliased or disjoint. So we've got one buffer that you're reading from, one buffer that you're writing to, the memory doesn't touch, and the cache lines that they get read into also are not shared. And if that's the case, I believe you can get a big speed up. So you can tell. I mean, I know there's hints in LLVM. I'm not going to use LLVM, but I know that there's hints you can send to LLVM to say, hey, these are not touching pieces of memory. Therefore, you're free to reorder the operations or do whatever optimizations, right? So you can do that with this like an underscore something. What is it in C++ and C? I'll look it up. Hang on a second. Disjoint C++ keyword. I don't know if that's the right thing to search for. Not. I don't know. As in non-aliasing. Restrict? Yeah, restrict. Yeah, right. Right. So, for example, if you don't need to read something into memory because you're not going to do an operation on it, I think you can write straight to it without bringing it into the cache first. I don't know about that one, but I definitely know that there's like non-temporal, what is it called? Non-temporal write in x64. Specialized instructions to write data directly to main memory while bypassing the cache. Yeah, that's what I'm talking about. Okay, so one of the ideas that I have is that when you're calling a function, you can specify, and you have to prove this to the compiler. So it's sort of like a contract. C++ is bringing out contracts, right? C++ contracts, I think. Or they've already had them or something. So you say like, okay, this is the contract. I'm going to say that in this function, the denominator is not 0 or something, right? And then that way, as long as you can prove that to the compiler, then you don't have to worry about a divide by 0 in this case. But in my case, it would be like reading and writing memory. And if you can prove that they're disjoint pieces of memory, then you can do certain optimizations. That's just one thing that I want to look at. Another one is, well, contracts, as I just alluded to. So you can have these sort of I guess, what are they called? Preconditions and postconditions, right? So if you break the contract, then it's like a compile error. And there's just a bunch of other small things that I want to test. That's really the main one. It's mostly about, well, there's another couple of things. I want to explore the idea of bringing pages into the language as a primitive. So, pages, when you get them from the operating system, they have different access permissions. So I don't know what I would even look for here. Like, I don't know, C++. It's not even a C++. Page. MSVC page. I'm not sure what to look for here. Like, maybe virtual alloc. Right, and you can get an mmap, I think it is, on Linux and Mac. So you have different allocation types, so different, whether you can read, write, or you can execute and read, etc. You can also make them write protected pages. So just what does it mean if you have that as a first class thing in your language? Hey Adam, how you doing? um, that's just a couple of things I want to look for, explore. And do I have a language spec? Well, you can kind of think I need a few things. So I need the ability to write bindings for foreign function interface, which is not really that hard actually. The vehicle broke down. That sucks. I need FFI. I'm not going to worry about modules or packages yet. It's going to be just one file is one object and then link them together or something. I'll figure it out as we go. I just don't want to think about the package problem because it's a huge decision. Language spec is like structs, enums, functions, arrays, slices, pointers, and of course the other feature that I talked about where you can, I'll show you in code. Maybe it'll make a bit more sense if I do that. So I've got like my do something procedure, and it's going to take my read from buffer, which is a read, and that's like a, I don't know, a byte pointer or something, a byte slice, and then write or a read write. So write, why did I say read from? This is like source and then destination. Okay, and this will be some other buffer, let's say. So in order to actually do, in order to prove that this is, let's say write only, I guess, and then we could just say like write, you know, for RW in, well, not RW, for A, B in source dest, B equals A plus 10 or something, I don't know, right? So all we're doing is writing into B. We probably have to get these by pointer or something. I'm not thinking too much about the syntax just yet, right? So these are going to be the same size, obviously, because we're doing like a double for loop. That's one of the like small syntax things that I want. If you do a for loop, you can have multiple iterators, and it'll just take the smallest size, I think, or it'll error, and if they're different sizes. I think that could also be an idea. But anyway, worst part is how expensive cars are getting, or vehicles. A drop shed costs $3,000 and a steel mill will only give $350. So for $350, I traded your van for a shed. Okay, is that good? I don't know. Yeah, Christopher, it's basically a zip. Do I want to release the language or is it just for fun and exploration? Well, I'm going to try it out first and I'll stream it while I'm doing that. And if it's useful, if it's useful, I'll release it. But I've only maintained one open source thing before in my life and it was so annoying. I don't know if I want to do that again. I'll have to think about it. I know that sounds very selfish, but you know, it's like having another job. So it's a big commitment, basically is what I'm saying. So I have to think about it. Yeah, we'll see. And finally, Leo, any tips on how to break down a problem that you want to solve? For example, when making Alexa, how do you break down that you need a start position, etc.? Well, with Alexa, I didn't really break it down. I already read how to make one. But I can give you another example. So for this week, the lesson that I want to get out today, but it might have to be Sunday, we're building a nav mesh in a 3D scene. And so I prefer to teach, when I'm teaching something, I prefer to try to think about it from first principles and then teach that method and also how to think about it. What I could have done is just Googled how do I make a nav mesh and then taught that. But then everyone could just Google it and teach it to themselves. It just seems kind of redundant. So I looked at the data that we've got. So we've got in the game that we're making, there's one model per scene. There's one model per scene, and each model has a bunch of meshes. And so we load in the model and all the meshes, and then we've got to figure out, okay, where can we walk? So first thing you might think is, well, in this kind of game, we're making an RPG, like an Octopath Traveler style. You might want to not walk on anything that's really sloped. So that's really easy. You can just get the triangle, find the center point, calculate the normal, do a dot product from the sky down, or dot product with up, the up vector, and figure out how sloped is this triangle. If it's too sloped, just not include that in the nav mesh. That's one thing. But then what you get is all of the roofs you can walk on, and all of the railings you can walk on top of them, and the pot plants you can walk on the pot plants. So you don't really want it to be just that. You need to have some other criteria. So what I'm working on now is I'm trying to think, okay, so I've got all these triangles, and we've got this sort of edit mode where you can open up the scene and you can edit the scene. So one thing you can do is you can drag spawners for NPCs in there, and you can change their flags and stuff, or you can drag in a trigger or a door, which can teleport you either to another place in the same scene or to another scene. And you have like settings on the side. And so there's this little editor. It's just a mini thing. It's not super featured like Unity or something. But you can still see the 3D scene, and you can click the meshes. So if you can do that, then what about if you can either click to sort of flood fill an area, or to remove the flood filled area? So you could have, for example, a button on the side that says, generate nav mesh automatically, and it will just generate the ones that has the roof on the top or whatever. And then you can just click the places that you don't want to walk, and then it will just have that. Or you could do the other way, where you don't click that button and you just click the places that you want to walk, and then it flood fills the area. Now, if you want to know how to flood fill something, well, probably depth first or breadth first search would be the starting point. I mean, that's the starting point I used. And then there are some really complicated algorithms, I think, for nav mesh, because as I said, I didn't look at what the state of the art is, but I didn't look at it, but I glanced at it, if that makes sense. So something about like voxelization and gradient calculations and things, I'm not doing that because I think that's kind of overkill for this game. So trying to make it, from the ground up, just think about what's the data that I have, what do I need? So what I need is a list of triangles you can walk on. So then I can add those to or even just the indices into the mesh, into the mesh, and then into the triangles. I can add those to the navigation state somewhere. So it's like, oh, these are the walkable triangles. And then we can calculate from that some kind of graph, right? So you also need to calculate a graph, because you don't want to be able to walk, if you're calculating a route through a scene and there's like a balcony up here and then there's a floor down there, you can't just walk between those triangles. But if you naively think that every triangle is a walkable thing that's connected to every other triangle, then yeah, you're gonna have some problems. So there's gonna be more steps to it, but anyway, I don't know if that helps. I hope it helped. Basically, just try to think about the data that you've got and what you want the other side of the data to be after the transformation. So in this case, I need a graph that I can compute a path on. That's the thing that I'm trying to make. And so how do I do that? There are some other problems. I'm kind of rambling here, but also if you've got big triangles, right? So imagine you've got a courtyard and it's just two big triangles, right? Well, if you just have one graph node per triangle, then, and let's say you choose the center of the triangle, they're only ever going to be able to walk when they walk through this courtyard just to those center points, unless you do some other thing, like while they're walking, maybe they calculate, oh, how close am I to it? If I'm close enough, I'll start walking to the next node or something like that. And maybe you could bolt some other things on top. Or I think what I'm going to do is I'm just going to take those center points and then do something called, I've covered this on my channel ages ago, but it didn't get like any views, but it's cool. Poisson disk sampling, if I can find an image here, which will basically allow me to get a sort of, can I open images in new tab? Yeah. A distribution of points around the area, and then I can just evict any that are not on walkable triangles. And then that way I've got all these sort of natural looking nodes, so people walk sort of around like, this natural way instead of directly to the center of a triangle every time, which can look weird. Anyway, it does help. Okay, great. That's good. So anyway, that's sort of some other stuff that I'm working on, but yeah. All right, let me just delete this. Yeah, I'll talk more about the language in a future video. I want to actually show more of the ideas. But first I've got to fix my dumb brain about this stack stuff. So, okay, before I answered those questions, we did have an error where the program crashed, right? And I believe it was because exit process is not a leaf. I'm going to call them procedure. Because I agree with Ginger Bill on this one. They should be called procedures. But anyway, it's not a leaf procedure. And in fact, if you look at like, what is it called? Win32 get proc address, even Microsoft agrees. Not that that means much these days. But I'm sure this function was written back in the golden days of Microsoft. Back in the 90s or something. Excuse me. I made sure to eat before I came on stream because I'm on a calorie deficit diet, so I'm super hungry. So I might burp a little bit. I apologize. All right, so this is not a leaf procedure, which means we have to allocate the shadow space, which it's such a... Why do they want to make the name mysterious? I mean, I guess you're shadowing the variables. That's why they called it that. Because you're copying them out of the register into this, which they call home here. So it's sometimes called home space or something. Yeah. Adam says oatmeal. Yes. Yes. I do want to try overnight oats or something like that. I just had like chicken, spinach, and celery, which was pretty nice. Complex carbohydrates. I could only eat some complex carbohydrates since like 3 years ago. My gut just, I don't know, my gene turned on or off. It's one of my genes, and I just can't process some of those. I get immense pain. Some idea it's behind Maine. Oh yeah. Yeah. Right, so we've got to allocate space for RCX, RDX, R8, and R9 on the stack, right? And also, I think for some reason yesterday I just wasn't really getting that stack grows down. I mean, I know everyone knows the stack grows down, right? But then when I was looking at the code, just wasn't registering. Oh, like shadow is behind. Okay, gotcha. Yeah, maybe. Yeah, it just makes it sound like mysterious and confusing to me. What would be a better name? I don't know. I'm pretty straightforward, so I would just say like parameter copy space or parameter, duplicated parameter space or something. All right. Okay, so now if we sub RSP32, I'm just going to run through this because I think it's going to be broken. I've got to actually sending your registers to the shadow realm. Yeah, nice. I'm just gonna, this isn't actually gonna run it, but I'm gonna run it in here. Because what I want to see is, what is RSP? So it ends in 8. So if RSP ends in 8, that means it's misaligned because it always needs to end in 0 before we call a function. So that means we subtract 8 again, run this, and there we go. Look at that. All right, cool. Sleepy, exhausted, brain rot. No. I like that. Sending registers to the Shadow Realm. That's good. Yeah. So I never would have thought that making, like, writing assembly, like normal assembly, would be harder than making your own virtual machine and assembly language, which is what I did for my game. That was easier than this. And it sounds silly, but yeah, interesting. It did help though. It definitely helped. Because, yeah, before I made that game, I didn't know assembly at all. I kept putting it off. Like, oh, I'm not going to use it. But then when I debug something that doesn't have, source code, and I'm looking at the assembly instructions, I'm like, I don't know what that means. So it wasn't really useful. But I put it off for years and years. Yeah, I don't know if Microsoft Assembly, or whatever this is called, like the best one to get started with. The Linux one is much simpler. What is it called? sysv? Yeah. sysv is much simpler. But, all right, so all we need to know is we need to allocate on non-leaf procedures 32 bytes, and then if it's unaligned, we need to align it. Okay, that's really it. ABI? Yeah, I guess it's the Microsoft x64 ABI. Is it Microsoft or is it... Yeah, it must be. Application binary interface, yeah. Just went in my eye. How did that happen? All right, so the next thing that I know I'm going to need to look at is this prologue and epilogue stuff. So every function that allocates stack space calls other functions, saves non-volatile registers, or uses exception handling, must have a prologue whose address limits are described in the unwind data. Whose address limits are described in the unwind data associated with the respective function table entry. Okay. I'm already confused. The prologue saves argument registers in their home addresses. Okay, that makes sense. If necessary, pushes non-volatile registers on the stack. Okay. Allocates the fixed part of the stack for locals and temporaries, and optionally establishes a frame pointer. Hang on a second. Do I need to do this manually? It does say that I do, if you allocate stack space or call other functions. Why have I not heard about this before? Epilogue code exists at each exit to a function. There's normally only one prologue. There can be many epilogues. I guess that's because you can return anywhere. Is that what that means? Epilogue trims a stack to its fixed allocation size, deallocates the fixed stack allocation, restores non-volatile registers. Yeah, and returns. Okay. Must follow a strict set of rules for the unwind code. Reliably unwind through exceptions and interrupts. These rules reduce the amount of unwind data required. Blah blah. No, I shouldn't skip over it. Instead, the unwind code can determine that an epilogue is being executed by scanning forward through a code stream to identify an epilogue. Okay, but who's doing this scanning? Is that me doing the scanning or the unwind code? Who's doing the unwind code? Yeah, anyway, if no frame pointer is used in the function, then the epilogue must first deallocate the fixed part of the stack. The non-volatile registers are popped. Okay, I need to... Volatile means it can be overwritten at any time, right? Non-volatile means you can store stuff in them. Is it, or is it the other way around? I really hope it's that way. Like, RCX, RDX, R8, and R9 are volatile, right? I wonder if it says anything in here. Volatile. Right, it says here on this page, which I already have open. Oh yeah, I used the X67, X87 before. X87. I was trying to figure out, if you guys don't know, the X87 is, I think it's a 20 byte register for floating point. I think it's 20 bytes. For X87, yeah, you can do some like floating point math in there. And I tried to use it once to see if, maybe while you're doing other floating point stuff, you could put some low priority floating point math in this, on these circuits, the X87 circuits. Anyway, it was just really slow. It was actually way slower because apparently I looked into it a bit. What happened is no one was using X87, so the newer CPUs just make the circuits really slow, and they all use a lot of pushing onto the stack rather than something faster. I don't know exactly, but yeah, they're just super slow. That was sad. I thought maybe we could do some cool side computation, but didn't work like that. Anyway, RAX, R10, R11, and XMM4 and XMM5 are considered volatile. Ah, okay, because RAX holds the return value. That makes sense. R10, R11. Why? What do they do? It's going to tell me in register usage. R10 and 11, they're used in syscall and sysret. Okay. XMM4 and XMM5, the floating point registers. Okay. Right. That's fine. So, as long as we don't store stuff in here, we're all good. Now, what I wasn't going to do that anyway, so that's actually, yeah, I remember looking at this before because I was storing something in R10, and then I realized it was not good. All right. So I think we got a bit of a handle on this. So I feel like I should do something more complicated. I don't even remember what we're doing in the language now. Let's have a look. What was I doing? NeoVim bindings. Hang on a second. There we go. So, alright. So I just wrote up here sub RSP40 in every proc decal. That doesn't need to be the case. Let's have a look. What is a proc decal? Oh, I don't have an LSP, which is fine, I guess. Parameters return type body. It's a node. Okay. If the body is a node, the body is a block with a bunch of statements. And if any of these statements are a call node, then the function calls other functions. I feel like I should maybe keep track of that when we're parsing, rather than looking it up now, if you know what I mean. So I didn't know if it's a leaf. I might just add here, like, is leaf. Okay, and then when we're parsing, now this is the parser. When we're parsing, we parse statements. Where are we doing that? Okay, so we've got parameter list. Yeah, parameter list here. End of the parameter list, return type, and then parse block. Okay. So parse block is going to parse a bunch of statements, and if any of them are call, we need to know that. I mean, I guess we could just look it up rather than doing it here. I don't know. Because now I'm thinking like, what am I thinking? I'm thinking I have to have like a parent here or something, which could just be nil, but then, or rather than parent, I'll say, because that's a bit ambiguous, procdecl or something. And then if we're parsing a call, it would be, where would that be? These are all statements. Right, yeah. Well, we don't have a way to parse a naked call or a bare call. Bare call, naked call, like something that's not being assigned. But we do parse an expression here, and now I've got to like color the expression function with this parent as well. Yeah, all right. Maybe I'll just look it up. I'll just look it up for now. I don't know if this is... I'm going to have to change this later. I'm sure of it. I'm sure of it. But that's fine. We'll just look it up when we're emitting. So I've basically got to say like... if the procdecl has a body, which... I guess it will always have a body, and we'll make a different one, which would be like an extern procdecl or something. So it's always going to have a body, okay, which is a node that has statements. I've got to do like a recursive search down. Surely there's a less dumb way to do this. I just need to know, does this procedure call other procedures? I don't have to go recursively. Just if any of these statements are a call. Yeah, that's fine. Okay. Problem is I have to like switch on the statement kind. This is not a good way to do this. I'm getting big resistance from my intuition. I really should do it here, I think. But when we're parsing a procedure, we're parsing a procedure. So that could be a state that we set, right? Yeah. All right. I think I found a better way. Maybe it's... I don't know what the correct way is, but whatever. Parsing, procedure, and we'll just put string, I guess. No. Node. Okay. Now, if we're parsing this procedure, at the moment, say, oh, this can't be just a, no, we can't do it like that. We've got to make it a stack, I think. Because it's going to be recursively going down. Oh no, I think this should work. Okay. So parsing procedure equals this node. Right, and then at the end of this, set this back to nil. But then at any point when we're parsing an expression, which is somewhere, where is this procedure? Man, there it is. Left is parse the lead. That's right. Parse call. Okay, here we go. We can just go to parse call. Okay, so when we parse a call, we say if p dot parsing expression is not equal to nil, then isLeaf equals false, something like that. No, data dot procDecl. Okay. Not false. Boolean. Yeah, I think that should work. Well, let's see. We can just have a look at the parser output and see if we get... I don't have to do this stuff. See what we get. So, what are we even parsing? Let's see. Oh. Has no field parsing expression. Oh yeah, it's not parsing expression. It's parsing procedure. Okay. Well, this doesn't tell me anything in the print, so I gotta go back to main, procDecl, and I guess I'll just print here, print value type, or parameter, blah, blah, blah. isLeaf. I don't know if this is, yeah, whatever. isLeaf, node dot data procDecl isLeaf question mark true, otherwise false. All right, well, let's see what that says. isLeaf false. Is that even true? Does main call another procedure? Wait, what are we even pausing? Hang on. Hello, on live Chromium? Confused me there. How come I'm emitting assembly rather than using something like LLVM? Because if I use LLVM, then I won't learn how to do the backend part of the compiler. And I've seen, you know, Bill Hall, Ginger Bill, Andrew Kelly, and Jonathan Blow all talk about how much they hate using LLVM after they used it for the languages. So I'm just not going to do that. Not that I have anything against LLVM, but I'd rather just learn how to do it myself. I think if I wanted to be faster, then yeah, obviously I should use LLVM, right? And also a bunch of other things I would probably use, like, what's that? There's a GNU, I don't know, GNU/Linux, whatever, tool where you can make a grammar for your language, and then that outputs like a BNF grammar or something, and then you can automatically generate a tokenizer and a parser. So, you know, I'd probably use that as well. I can't remember what those things are called though. isLeaf false. Yeah, I need to actually look at the file. Is this the file we're parsing? I don't think so. Yak and Bison, Lex and Yak. Yeah, those are the ones, yeah. That's right. 07, there we go. All right, we're parsing this, which just returns the value 42, which means it is a leaf, because it just returns a number, it doesn't call anything. So, this is wrong. Oh, because Yeah, I should probably say by default isn't a leaf or something. I know it sounds silly. Is leaf is Terminator. No, leaf is the same. Whatever. I'm overthinking it. I'm just gonna call it isn't leaf. Double negatives, no, they're kind of confusing. Alright. So when we make a proc decal, where is it? Up here. N dot is leaf. I'm just gonna set it to true. There we go. That should hopefully solve this problem. Right, and dot data dot proc decal. There we go. Alright, so it is a leaf, that's correct. Now let's try a different file. And not this one. Yeah, maybe this one. Okay, so we got add slices is a leaf. Hang on, let me go back to that file. That's true. And main is not a leaf. That's correct. And add is leaf. True. Okay, cool. So it's correctly working, which is what we wanted. Now, is that going to be enough? When we emit, we have to check if this is a leaf, and then we do this. So if n.data.proc, if it's not a leaf, rather, proc decal is leaf. If it's not a leaf, okay, we have to allocate 32 bytes for the shadow space, but then, so this is where it might get a bit confusing, because I know once we add push and pop, this is going to be different. I think for now we're safe to just do 30 and 8, probably not as separate instructions, but I'll just do it as separate instructions for now. And that should give us, hopefully, the correct result. So what we want to do here is when we return 42, we want to call a procedure, which then calls exit process, which we don't have because I haven't added extern to the compiler yet, or I haven't added directives either. Not extern process, exit process. And does this take a value? What's the actual signature? I think it does. The return value, exit code, yeah. So I'll just say U32 for that one. And that's not the right. That's not how this language works. Okay, so it should look like this. So this is how the foreign function interface is going to work. You just use extern. And then we've got to link it against Windows. I feel like maybe I'm getting a bit too ahead of myself here. What I should probably do is just... oh, I don't detect comments yet. Hey, what do you guys think? I was going to use the Lua style comments, which is dash dash, but then you could never do something like, well, it would add extra complexity. If you did like 2 minus -3 or something, 2 minus -3 rather, that would turn this into a comment, or it would have to look ahead and check if this is a number, but then also maybe this guy's just saying like 3 eggs in the basket and he meant to type the comment there. Yeah, maybe I should just go with // hey, because then it doesn't have this problem. Oh, well. Aesthetically, I like the Lua comments more, but whatever, it's fine. Well, since I don't have comments, I just can't even add that. So return No, not even return. Oh yeah, that's right. What am I saying? This by itself is supposed to call exit process on the output. Well, in this case, because we're compiling for Windows, linking against the Windows libraries. So, what do we actually get? You like the Lua ones too, Chief? Yeah, it's pretty nice. Maybe I'll do it. Christopher says, if you had some state in Alexa, you could say, I read a white space, and then only then accept a comment. And if it wasn't reset, the read white space boolean. True. True. Yeah, that could work. So it would have to be either a new line or a space. And then if you start comment with no space, it's just invalid syntax. That could work. All right. I forgot what we're doing. Oh yeah. Trying to make this work. Okay, so move RSP40. That is totally incorrect. Use backslash. Yeah, I don't know about that. Okay. Yeah. Man, yesterday my brain was not in a good place. But hey, that's okay. We're making it. We're making it. Oh, there's another thing. I don't know how relevant this is going to be depending on what you're doing, but I was pretty nervous about starting streaming again. And I was like, maybe I should just make YouTube videos because then I can edit them better and, you know, blah, 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 etc. But I've been streaming, what, six work days in a row now? Not for too long, just like an hour or hour and a half per stream. And the YouTube analytics are way better than I was expecting, which is interesting. So the point I'm getting at is just try stuff, see what works, instead of worrying about, like, I always try to project forward and think about how it's going to turn out. I think that's maybe not the best thing to do all the time. Obviously, I don't want to just do anything at all times and like never think about anything, because that's, I don't know if you guys saw that video recently. It was pretty popular, about dual maxing, the Chinese guy who is breaking down Hamlet. Oh, that was a good video. You should check it out. It's called like The Benefits of Retard Maxing or something like that. Anyway, it's really good. His humor is great. But yeah, you can get stuck just overthinking stuff forever and not do anything, not take action, and then that's worse. That's way worse. So anyway, all right. So we got a leaf. Is this going to be a valid program? It looks. No, that's not going to run. Move ECX, EAX. Yep. Move REX42, return. Right, yeah, so that's the return value. Always the good old hash, now that you think about it. That's true, but I'm going to use hash for directives for the compiler. So like for struct, oh, this is another thing I want to look at, by the way. And I believe C++ is adding this. It's like they're just taking all the ideas out of my brain. Or maybe it's just ideas whose time have come. So like cache line aligned struct, for example. So, or you could also do something like, you know, maybe like get the cache line size, but then that might be not, that wouldn't be here. That would be different. So like getting the cache line size could be something like, let's say you're inside a procedure, you want the cache line size for your hardware, then you could maybe, I think I'm gonna take this from Zig. Not cache line size, but the at, or what do they call them? They're not directives, they're built-ins. Yeah, built-in procedures. So this would return on my computer, what, 64 bytes? And then on Macs, I think it returns 128. And I'm only targeting x64 platforms. So yeah, there's some other things as well that we can look at later. Why is that useful? Because if you can align things to the cache line, then you can make sure that they don't share the same cache line, which stops something called false sharing. Intrinsics? Yeah, maybe in called intrinsics. Right, so different threads can operate on the data without having to lock. Yeah. So anyway, we're going to look more into this later. Oh yeah. Also want to bring threads up. Threads and SIMD. There was a video recently, I think Primeagen covered it. He covered Mitchell Hashimoto saying everyone should learn SIMD. I agree. Everyone should learn SIMD. Because if you don't learn it, then it's just this really powerful part of your CPU that's sitting there and you never do anything with it. So I'm not an expert at it or anything, but I've used it before and it's very good. Very good for performance. Yeah, you're going to get those arguments. There's some more philosophical stuff that I want to talk about later, which maybe I will, about why I'm building this language. Has to do with the material plane and stuff. But a common thing that people say is, oh, I don't need performance. It sounds like all you care about is performance. Blah, 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 performance, etc. But it's not about performance. It's about, we're doing this thing, which is programming this computer that we've built in the material world, right? There's no transcendent aspect. There's no interpretation that you can add. It's not something like, you know, a piece of art where it all affects us differently because we have to interpret it through our consciousness. It's like, this is a empiricist wet dream, right? Computers. Everything is exactly as we make it. So why do we make programming languages where things are up to interpretation? It just doesn't make sense to me. But anyway, I'm going to talk more about that later. But yeah, that's part of the impetus as well. So this looks like it's working at the moment. I think I'm going to actually try to compile this. So are we outputting this to a file? Where is this even going? We're printing it and we're not writing it out to a file. So I'm going to write it out to, Chief says data in, data out. Basically, yeah. Exactly. So I think there's something going on here where people are trying to attach sort of a metaphysical aspect to programming that just doesn't need to be there. Not that I'm against metaphysics or religion or, you know, transcendence or anything like that. Just this thing that we're doing is totally in the material world, so why don't we just keep it there? Write entire file from bytes, yeah. So we're writing it to out.asm. I think this returns an error, but I don't remember how to. I can't get any help. No help available. All right. OS Odin package. Write entire file from bytes. Okay, permissions. Write user, that's fine. It does return an error. And I'm just going to ignore that error. I think that'll work. That doesn't work. Why? Because Cannot assign value program of type string. Ah, okay. Well, then I'll just use the string version. Or I'll just remove this. Okay. Now we've got out.asm. Oh, I just opened it in Helix. Whoops. My muscle memory is too strong. Okay, that looks good. I think. I don't think this needs to be a global main, does it? Maybe it does. I don't know how that... I need to learn about that right now. Right now. Not global main. NASM global in section text. Makes it visible to the linker. Yeah. Yeah, we don't need to... That doesn't need to be there, because the linker doesn't need to know about that. Because we're calling it. So, where did I emit that? Here. Only start if main exists, I guess. DLLs don't use main. Yeah. I'll just write the full comment there just to make it very clear. Run? No. That's not the right thing that I'm supposed to be doing. Odin run code, that's right, okay. Okay, looks good. Let's finally assemble this. It's called out. Now we've got an out dot. We do not. Oh, we have an out.obj. Yeah, and then LOD link, etc. Now we've got out.exe, and I'm just going to move that to test. Actually, I'm not going to do that. I'll just edit this. It'll just take me like 1 second to do that, but I just didn't want to do it. All right, here we go. Cool. So let's have a look here. We have now hopefully aligned the stack. Where is the stack? Oh, I didn't actually go into the call. Whatever, who cares? So inside EAX is the value 42. That's 42, right? 0x2a. And we're done. All right, that looks good. Wow. Okay, we have successfully conquered the shadow space. That's great. Now there's going to be more of this stuff that comes up later when we need to push and pop onto the stack. I'm pretty sure. But what did we just do? We actually made this. Let's just change this number to 123, and I'll do Odin run code, and then let me just edit this quickly. All right, out. Oops. One, two, three. There we go. All right, so we now have a successful. Okay, we're going from lexing, parsing, and then doing no checking at all, and then lowering it into assembly. So that's cool. So this could probably say whatever. I think this could say like whatever type, and I think it would still just work. Yeah. Because there's no type checking. So this doesn't mean anything. It's just a hint. So yeah, we probably want to change that at some point. Some point soon-ish. No checking is your favorite, Christopher? Yeah. Yeah, same. No, not really. I'm sort of like, I don't like Rust because I felt like I was a hostage. But I also don't like JavaScript or etc., where anything is just like the types just don't mean anything really. So yeah, I'm more of an in-between kind of guy. I do like types. I think they're useful. Type safety is a social construct, eh, Chief? Sure is. Just like every other part of computing, I guess. All right. What are we going to do next? Why didn't I think of this before I started the stream? Okay, let's see. Type safety is a skill issue. Hey Joe, how you doing? Yeah, I know your opinions about types. You like those gradual types, right? The toy scripting language has a minor amount of checking, but it's not really like proper check. There are cases where you can write invalid code. Yeah, I mean, excuse me. If it's just a toy, then that's fine. You know, I remember once in one of my videos, I said I didn't like the idea of undefined behavior, and all these C nodes got angry at me. Like, really angry. I think one of the comments was, I lost all respect for you after you said that. I just find that so funny. Why do you care that much about someone's opinion about undefined behavior? That's crazy. But okay. I just... Why would it be desirable? Well, I don't think it's a desirable thing, but I don't know the arguments exactly, so I don't want to misrepresent anyone. I think it's because C compiler developers use undefined behavior to make optimizations. So therefore, undefined behavior makes faster code, therefore undefined behavior good. That's what I think is happening, but you know, as I don't want to misrepresent people, but that's just my feeling about it. I think that's what's going on. Also, I mean, the more cynical answer could be, if you know all of the undefined behavior stuff, it makes you feel smarter. That's... I don't know if that's what's going on. I'm not saying that. I'm just saying that's a cynical take that you could have. Just define it to be optimized? Yeah, that's right, Christopher. Joe says, yeah, sure, but can't you define the performance enhancements? I've heard the same argument, but I have to see the exact undefined behavior used and what the benefit is. Yeah, I need more specific information as well, I think. Like, for example, if the programmer had more control over how to tell the compiler things, would you even need undefined behavior? I don't know. Because, like, there's a good talk by, what's his name? Tony Albrecht. Tony Albrecht? I don't know how to say his last name. I think that's how you say it. Albrecht. He works, or did work, for Riot Games at the time that he did the talk. And something that stuck with me is he was talking about optimizing basically object-oriented code to be more data-oriented or something like that. But the thing that stuck with me was he said when compiling C and C++ code, the compiler can only fix like 10% of the code, right? The other 90% is up to you. So if you don't know what's going on and you just expect the compiler to do it for you, it's just not gonna happen. Abdul says, in C, too many things are undefined behavior that shouldn't be. Part of it is C having bad semantics. Yeah, it could be. I don't know exactly. I'm not sure what good semantics would look like in comparison. But yeah, part of the things that I want to explore with this language is sort of bringing more of these hardware concepts up into the language itself. But something you got to remember about C is it was made in 1972, right? And at that time, I think it was 1972. At that time, there was tons of different platforms that people were using, even for just personal computing. So it wasn't like now where I can just write a language and the only thing I care about is x64 because that's what everyone uses. It wasn't like that. So they even had to support different byte lengths, like different amounts of bits per byte, different amounts of register sizes, different types of CPUs with different amounts of registers, and yeah, so it's different time, totally different requirements for the language. So I think we're at sort of an advantage here, and we can utilize the case that CPUs have mostly been normalized around x64 and ARM64. So yeah, hopefully that leads to advancements in the programming language field. Rise says there's an Eskil Steenberg video on undefined behavior. It explains how undefined behavior can lead to compile optimizations. Oh, thanks. Yeah, I'll check that out. I do like Eskil's stuff. I don't think I agree with him about C being a perfect language, but that makes sense since I'm making a language. If I thought C was perfect, then I wouldn't do this. Yeah. But yeah, I like his stuff. His How to Program C video really inspired me when I watched it. It was very useful. I recommend that if you want to get into C programming for sure. Just a lot of the stuff that he does is sane, as in not insane. So that's good. What were we looking at? So we've got procedure calls. They work. Wow. Maybe we can make something like, can we make this work? X, S32, Y, S32. Abdul says, yes, the assumption that we have no idea what the language will run on is why C has so much undefined behavior. Yeah, that makes sense. And so that's why when I say that I don't like undefined behavior, I don't think it should be in a language, I'm not knocking the fact that C has it. Right? I understand the historical context of why it exists. But, people attach their egos to stuff and they get big mad. So, that's fine. Maybe that's a bit dismissive, but no, I don't think it is dismissive. That is what's happening. Is this going to work? Well, let's find out, eh? Alright, so we've got... I need to fix this printing. But anyway, we've got a procedure declaration. It's not a leaf, that's correct. It calls add number 40 and 2, and that's what it returns. This is a leaf, that's true. And it has two parameters, both S32s. Adds X and Y together, returns that. Alright, so this should maybe run. Let's find out. No. Error, expression, syntax error. Alright, let's have a look. Huh. Okay, my my add has a literal plus sign in here. Whoops. That's not how add works. So when we're emitting a return, no. Alright, so that part's all fine. That also is not correct. We don't move into RAX add, we call add. Alright. Oh, okay, because I'm only supporting this, like return 42, or whatever, 123. Alright, so I need to actually, because this is hard-coded, I need to not hard-code this. GC, there we go. Getting used to these NeoVim shortcuts. I know I could just rebind everything to be like Helix, I guess. Alright, so we need to we need to know what it is we're returning, and it could be an expression. So that's an interesting conundrum. Christopher says, why am I using NeoVim over Helix? It's literally for two things. Literally. So literally for two things. One is, I can add syntax highlighting to YouTube's catching up to Twitch with those ad breaks. I'm sorry, I would like to turn off ads on my channel, but even though YouTube says that they don't penalize you for if you turn off ads, I'm pretty sure they do. I don't make much money from ads. Like, basically, I'm not going to say basically nothing, because it's relative, but it's like, I think like 25 USD a month from ads, which is, I mean, it's not nothing, but it's not much. You were taught AT&T syntax at school, Joe, and Intel syntax is so much cleaner. Yeah, so I'm using NASM specifically because I don't want to do... Where is it? Yeah, I don't like the... I think there's like percent signs everywhere and stuff. And also... Yeah, anyway. This is actually net-wide assembly, which is nice. And also, I like having the destination as the first parameter. Sub into RSP or from RSP to value 32, whatever. Yeah. And what was I looking for? I got sidetracked. Oh yeah, the features. Right, so one of the features is my language can have syntax highlighting without having an LSP or any kind of tree sitter plugin or something. It's not perfect, but it looks okay. And the other one is vertical split. You can actually move it to the side. So if I do like 20, Control W, whatever, right? You can resize the vertical split. In Helix, you can't do that. You have to have it just split in the middle, right? So when I was looking at the language code on the left, or on the right, whatever, I just wanted to have it on one side so I could see what it was that I was parsing, and I was writing the parser. But because it was split down the middle, parsing code was going off the side of the screen, and it was just annoying. Those are the two things. That's why I'm using NeoVim. Abdul says Phasm is also great. I don't know Phasm. Let's have a look. Flat assembler. Okay. Got a suspiciously minimalist web page, which is good. That's usually a good sign. All right, let's have a look. Base converter. I don't want to download a zip. What is this? Introduction and overview. Okay, DB90H. What is that? That's a string? DB. Is DB string? I can't remember now. DB some data. Oh, you can do macros and stuff. Yeah. Okay. It's pretty advanced, I guess. Excuse me. Yeah, I'm not sure. I'll have to look at that another time. But now, I think NASM is good because it's familiar and it runs on Linux. So even though... Oh, you think Soding's a fan of Phasm? Okay. I don't know how to say his name. Is that how you say his name? Even though... What was I going to say? I forgot now. That's all right. Let's just try to fix this, eh? So we're emitting a plus sign. You don't know how to say Soding either. I'm pretty sure he says his name at the start of his streams, but it's so What is he? What is he? Russian or some kind of Eastern European? I don't know. I just it's so different to English. It just never sticks in my head. Hmm. All right. Why are we omitting a plus sign here? Because we're omitting the leaf token text. That's a problem. But also move RAX add. That's also a problem. Where was that? That was this as well. So this code is definitely not how we want to do it. Okay. The problem is if we're parsing a return, we might come across a call, and if we're gonna do a call, we need to. Well, I guess we can do it like emit call. I'm just gonna make a function for this, like procedure. Am I ever gonna stop saying function? I don't know. Oh. We need to pass in the string builder and the node. Hotkey is different. There we go. Cool. So, when we emit a call, what do we need to do? Well, if it's a, remember, if it's a leaf, we don't need to do anything with the setting up the stack. But if it's not a leaf, we need to do sub RSP32, and then we need to see if that's aligned. But I think it's always going to be aligned until we start adding pop and push, just because we do this at the beginning. So, yeah, I think what we want to do, I'm still doing this directly in text, like writing a string builder, but later, like, can I, yeah, later I want to make some kind of intermediate representation. But for now, we'll just do this. Okay, so what are we doing here? We're going to, I'm not writing a string. We need to sub RSP 32, I think. The 32 bytes for shadow space, and then, but then 8 bytes for the return address. I think we still need to do 40. I'll figure that out in a bit. But we only need to do this if the call, this is a call. What's on the call? I see, this is a problem. The problem is, I need to know if the procedure we're calling is a leaf or not. And we don't know that at this stage because we're not writing the procedure, we're writing a call to the procedure, which means we need to, I guess we could just store a lookup if we want when we're pausing, which is sort of what I avoided doing this previously, but you know, something like this, and we can look them up by name, look up the procedures by name. Didn't we already store procedures somewhere? Well, they're stored on, yeah, they're stored on the file node. That's funny. Maybe this doesn't even need to exist. Yeah, interesting. Abdul says, no, the return address of the function that you called is already taking up 8 bytes of the stack space. Right, so you're saying that I only need to subtract 32 here for the shadow space, for the 8, for the 4 parameters rather. I think it's pretty delayed. Something I don't like about YouTube. I do want to start streaming on Twitch at some point. I just haven't fixed it yet. I'm just going to double store these for now. Worry about it later. And I'll call it procedures just to be... Yes, 32. Oh, thanks, Abdul. I appreciate that. All right, so it's already stored when we call into it. Okay. When we call into main. It's already stored here. Okay, yeah. Ah, this one. Clap your hands and you'll type and send back quickly. I think the delay's 30 seconds, but okay, sure. Hang on, I need to get like a timer up then. Timer. Okay, stopwatch. All right, I'm just gonna start the stopwatch. How about that? Rather than clapping my hands. Clap. Okay. 2, 3. 15 seconds. Maybe 15 seconds. Yeah. Okay, that's not too bad, I guess. Okay, so emit call. Pass in a string builder. Pass in the node. What node are we passing in? It's the return node. Okay. Wait, what was here just before? No, it's not the return node, it's the expression. Okay, so I'm going to call whatever this is. This doesn't make any sense. What am I doing? I'm going to need to do this if the end.data. No, not end.kind is equal to all. But then that's what this switch case is. That's what this switch statement is already for. Right? We just have a call case and then how does this even get called? I need to rename this from emit file. Feels like 15 makes sense. Yeah. I need to rename this from emit file because it's doing my head in a little bit here. So I'm going to say this can be emit program. And how do I've forgotten how to do the Vim search. It's like search for all emit file, replace with emit. There we go. Okay. Cool. Now in main, emit program. There we go. All right. So now I can recursively call emit and it doesn't break my brain. That's good. So emit call doesn't make sense either. Okay, I need to like sketch this out in the code or something here. So we've got Christopher says the best you can do in Vim is get stuck in the macro recorder when you're intending to exit. Yeah, that happened to me a lot in my life when I first started using Vim. Definitely. So we're trying to return my proc 123, something like this, right? We're trying to not pause, we're trying to emit this. So it's a return statement. So what does our return statement look like? Let's have a look at that. Return, it's got a return type. on here. Oh, I'm searching for return. It's going to be everywhere. Here it is. Okay, so it's just got a leaf, which is some expression. Okay, that makes more sense. So we want to set up this, maybe not. Whoops. I'm just gonna delete all this stuff. All right. So this is going to be. This is the leaf, which is stored on n.data.leaf. So what we want to do is just emit this, because it already knows what type it is. So it could be a call, but then if this is a return, then we want to do, well, it's going to be an RAX already, so I just think we just do return, right? Because if this is a call, it's going to set it up, call the procedure, it's going to store the value in RAX, the return value. Now that there's only one return value, but when we have multiple return values, this is going to get interesting. All right, and then we just write return, I think. And here I'm just gonna strings. That's not correct. Oh my god, I can't type. I'm gonna write the string. It's gonna be a comment that says call. Oh yeah, I forgot you can use that. fmt.sbprintfln. I should be using this. It takes a string builder and a format string. Called, and then you can add in, what is this called? n.token.text. I think that'll work. Yeah, I should be using this procedure, not write string. But anyway. Alright, so we got some errors. Oh yeah. We're not using this right now, so we'll just comment it out. Or try to comment it out. There we go. Keep alignment in mind as well, says Abdul. RSP has to be 16 byte aligned at the call. Yeah, that's right. So it has to always end in 0 in hex. Yeah, that's probably gonna do my head in many times. So in some cases you might need to allocate an additional 8 bytes. Yeah. Thanks for that. Yeah, I just want to see what I can get into the assembly for now. Okay, and we need to call emit and pass in the string builder as well. All right, that's good. And now we just look at that. So is it this file? All right, here we go. All right, so obviously this code is not correct. I just want to see what happened. Called add. Okay, that's good. Return add. Well, obviously that's not correct. Fine. So we did receive a call node. That's good. Now return. That probably needs a new line, or we use the other. It's a bit nicer, isn't it? All right, there we go. Okay. Right. We also need to add a tab at the beginning. Cool. I'd like that the buffer's updating. I mean, I don't know if I like that actually. I like it now, but sometimes you have a file open and then you're doing something like, I don't know, parsing some data or whatever, and you're looking at the file, and maybe you want to change something, but then the program that you wrote to parse the data updates the file, and then if it just changes before you can save it, that could be a problem. But anyway, okay, called add and move the value into RAX. That's the idea here, and then return. Okay, but add doesn't do anything. Why does add not do anything? Because we only parse the return. We don't actually... Ah, right. I'm gonna put up here, I guess up here, just some emitted comment code that always gets put in. And it's gonna be n.token.text. Let's see what happens if we do that. All right. So we're parsing add, return plus return. We're parsing main, return add, called add. Okay. Okay. Cool. So plus ret. So we have to parse a binary operator instruction. So what are they called again? Is it just bin binary op? So in this case, we have a bunch of different binary ops, but we probably just want to switch on the... Well, what data do we have in there? Left and right, and the operator is just a token kind. Okay. So we want to switch on n.data.token.kind, or is it text? No, kind. Yeah, kind. All right. In this case, we've got a plus, so we'll just handle that right now. So we're adding together something into something. Now this is where it's going to get complicated, but I'll try to keep it simple for now. So we're going to print basically an add, and we're going to add to somewhere, but we don't know where. So we probably shouldn't just add to RAX, because that's the return value of the procedure, and we might be clobbering something. No, we can't be clobbering something. Maybe we can add to RAX actually. But we have to know what we're adding, right? So we're adding two values together. Abdul says, better to have a separate enum for the binary operator kind, since the same symbol can have two meanings or more depending on the context. For example, multiply and dereference are both a star. That's true, but I've already taken care of that in the parsing stage, where star is going to give you a unary operator rather than a binary operator, unless there's something that I missed. So in this case, it would be different case here. So it'd be unary op, and then the star would be dereference. All right, so we don't know what we're adding together because this comes from a call. Okay, maybe I need to like make something simpler first. Rather than this, why don't we try z equals x plus y, x equals 40, y equals 2, and we can return z. Except these has to be S32. We just won't have add for now. Maybe trying to parse this or omit this program first would be better. String literal is not terminated. Oh yeah, right. Okay, yes. What's wrong with this? Enter data. Oh yeah, not data token, just token. Alright, what do we make? We made nothing because we don't handle any of this at all. So this is a var decal. And for a variable declaration, hang on a second. So we're declaring a variable. Where does that variable go? Obviously, we could put it in a register, but then we're going to run out of registers eventually. We have to know which registers are being used right now in the current scope. And which ones are free by extension. And also, how do we refer to their names? So like, we know that we have X, Y, and a Z, but the assembly language doesn't have the name X, Y, and Z. Unless I'm blanking. I'm pretty sure I'm not blanking. I'm pretty sure you don't have variable names. You just move values into registers and then remember which ones you're using. Or onto the stack. So, I mean, I think that we could do stack allocation, right? Just push these onto the stack and then remember which ones they were. I don't actually know. I'm going to actually look up Godbolt here. This might help. I know it's not called that. It's called Compiler Explorer. But we look at, just going to change this to like int x equals 40, int y equals 2. Abdul says look up Windows x64 colon convention. Okay, I'll look it up again in a second. Let me just look at this. All right. Okay, so wait, why EDI? Oh wait, hang on. This is gonna be different. I don't know if there's Microsoft available here, is there? Maybe there is. Oh yeah, MSVC x64. Sure, gonna work. It's only permitted for internal evaluation purposes, otherwise governed by the MSVC license agreement. Okay. All right. Oh wow, so it made global names? Oh no, that's offsets. 0, 4, and 8. Uh-huh. Yeah, maybe I should look at that page. Calling conventions. I have it open here. Parameter parsing. Yeah, that's not what I want to look at. Exactly. unprototyped functions, return values. Caller and callee saved registers. Yeah, so I know not to put data into these ones. So I guess, I'm not sure if this is how other people do it, but I assume that you just keep a list of which registers in the current call stack are being used by the current call stack, and then if they're all used, you would start pushing to the stack. But if there's free ones, then you would use the free ones, I think. As long as, obviously, as long as they're non-volatile and also not, yeah, non-volatile, right? So not any of these ones. So RBX, RBP, RDI, RSI, RSP, R12, 13, 14, 15. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have 9 64-bit 64-bit variables before we have to start pushing onto the stack if they're integers. I don't really understand why you can't just temporarily store. You probably can temporarily store in XMM6 to XMM15. They're 128 bits, right? So you could store 4 integers in there, but you just can't operate on them. So you'd have to move them back out into another register to do ops. You should be able to use them as storage, right? We know we don't use the x87 FPU. Yeah, it just doesn't perform very well. Christopher says you can do something like a graph coloring with lifetimes of registers to know which is used and free, and then use the stack when you overflow. Yeah, never done it yourself, but I think kind of okay. Cool. Abdul says XMM are for floats, I think. Yeah, that's right. They are for float operations, but can you just put the bits in there for now and then use them, like grab them out later? I don't know if that's worth doing. I just don't know if that's possible. Should be, right? I mean, bits are bits. But they might get interpreted differently. I don't know what happens under the hood. I don't think they would. Let's see. All right, so I think what we'll do is we'll make, I guess we'll make maybe a map or a bit set or something. Yeah, maybe a bit set of the registers. So like register, and then we just have to add the registers here. But how do I want to do, like 16-bit registers, and then there's 32-bit registers, 8-bit registers, and 64-bit registers. Probably don't want to overcomplicate it right now. So my eye is twitching. It's very annoying. Stop twitching. So I just want to look at these non-volatile. These are volatile. These are non-volatile. Okay. I guess I just add all of them. RAX, RCX, RDX, R8, R9, R10. Okay, so those are the volatile, and then you know what's weird? How is RSP non-volatile when isn't that where the stack pointer is all the time? So if you override that value, isn't that going to mess up like your whole program? Anyway, maybe I don't understand that properly. Non-volatile. Non-volatile, there we go. Okay. Yeah, well, I'm not going to worry about floats yet. So, yeah, I'll do that later. I don't know if this computer has AVX 512, and basically no one has it at the moment still, which kind of sucks. Non-volatile means the function has to restore the original value after it's used. Thank you. That is very helpful. Okay, I'm going to put a note here from Abdul. Right, in the case of RSP, this is automatic because of the stack. I don't quite understand that. Does that mean that it's already handled for us, so we don't have to worry about it? Okay, right. Hang on a second. So that means I need to store values in volatile registers, and then oh, I get it. I can put whatever I want in there because it's considered volatile, which means I don't have to restore the value. So I can actually use these registers. Now, obviously, these are the ones for parameters. Christopher says, clearing the stack frame at the end is restored to the state before call, I think. Abdul says, you push onto the stack when you call, you pop when you return. Hope that makes sense. Right, yeah. Okay, right. So RSP, yeah, is incrementing and decrementing because of that. But that, yeah, but, okay, yeah. But then if you just override this value randomly, it's going to break your program, right? Let's say I write 1000 in here for some reason, because I want to store the number 1000 in a non-volatile register. It's like it's backwards terminology, but maybe it's just the way I'm thinking about it. I get it now. I get it now. So that's why you can put your parameters in here, in volatile. And the return value goes in REX, parameters go in, is it RCX, RDX, R8, R9? I think it is, yeah. Oh, it's RCX, RDX, R8, R9, yeah. And then stack, yeah. Okay, so I'm going to put here, just going to make this a note. So these are volatile. We can use these, or we can leave whatever data in here. I think that's what that means. Is that right? Return value, and then RCX, RDX, R8, and R9. These are for int params. Params, can I type? No. And these are just other things we can use. Okay. All right. So, man, this is getting more complicated really quickly. That's fine. Well, to reach my deadline of 2027, I might have to stream more. Can't stream more this week, but next week I can maybe stream more at nighttime. That's compilers, baby. Yeah, that's right. Okay. Yeah, I want to do this whole thing on stream if possible, but it might not be the best idea because, well, I have to try to be a little bit entertaining if that's possible. It's hard. And then also, figure out problems. And then also some of the streams might just be really boring, like super mechanical work that's just tedious. But hey, we'll see how it goes. All right, let's see. Chat is distraction for deep think mode. Well, I don't know. I feel like I'm getting a brain upgrade right now. Thanks to you guys. It's definitely been helpful. So maybe it's better to be streaming. Except when I keep forgetting what I'm doing. But I don't think that's your fault. That's because crowdthink, yeah. It's just because my calorie deficit, I think. Should have started this 6 weeks ago when I wasn't on a calorie deficit. Okay. What do we got? What do we got? All right, let's look at this. Okay, so let's just say we've got a binary operation. No, we've got a var decal. Okay, so we've got to put this variable somewhere. So I'm gonna keep this state here, I guess. This is gonna get messy. Am I staying properly hydrated? I'm drinking water. I don't know if it's properly hydrated, but trying. Okay, so I can see a problem that I'm going to have in a second, but luckily there's only 2 procedures so far, so it's not a big deal. I'm going to put the string builder on here. And then I'm also going to put, I don't know what to call it, but just, I don't know, use registers. Good enough, you forget to bring water to the desk. Well, actually, before I started streaming, I just didn't have water at my desk, like ever. I need it because I'm talking so much, I think. My mouth gets very dry. Otherwise, I would just sit here working until I got a headache, and then I would get water, which is really not good. Is it the right syntax for a bit set? I think so. So what we can do is when we've used the register, we can turn this on, and then we can just check for the next unused one or something. Maybe it should be a stack. What are the operations that we have available? I don't want to think too much about it. Let's just do the first thing that we can think of, and then we'll try that first. So here I'm going to say, create this struct on the stack, and call this string builder. See, this is where NeoVim needs multiple cursors. I really don't understand why it doesn't exist in this editor. Yeah, because you should just use macros. No, you wouldn't get it. Alright, so we're going to pass in this, we're going to pass around this emit struct instead, and I'm just going to pass in emit string builder to these, and I have to keep doing this. Okay, and e dot, okay, there we go. No, this one needs to be just e. Emit call is not a thing yet. But I'll update this anyway. I probably forgot something. Let's just try to run it and see what's broken. Alright. Cannot assign builder to emit, yeah. Okay. Where's that? I don't know how Git just got run, but anyway. Okay, line 30. Forgot the E. Line 47. No, that one. 58. I can see one right there, which is on line 66. And line 80. All right. Cool. I didn't actually do anything, right? What did I just do? Oh yeah, I just added this state here. So use registers, that's like registers that are currently used for the call stack that we're in. So I guess as we unwind, we have to mark them as not used anymore. That way when we're declaring local variables, like in here, I could say, I don't know exactly how I want to do this. I'm thinking too much ahead. Let's go to use registers. How do I get the first 0 in that? Put in overview. And I want to look at bit set. So membership, not in, inclusive range, half open, range, not in. All right, I'm just gonna make a procedure. Register, okay, get available register, and if it's not okay, then like push to stack, and then I don't know how to do that yet, but we'll figure that out later. Get first available, or just get available register, sure. And we want to return register ball. So I suppose the easiest thing to do is just to say, God, I don't like this, the way that it does the view. For, wait, can we for loop over a bit set? Yes. Condition only for loop, range loop. In and not in are allowed within a loop condition without ambiguity. Okay. So for r in e dot used registers. I don't know what this value is going to be. Is it just going to be 0 or 1? I don't know. Let's have a look. Is this even going to do anything? Or run? Expected a maximum of 1 identifier. Got 2. Okay, so we can't do that. That's fine. Missing return statement. Oh yeah. Return. Excuse me. Right. That just didn't run, I guess. Or something else happening. I really should just use the debugger like 100% of the time, like Nick Barker. But sometimes I don't use it. you can at least loop for E in enum name and then index yourself. Yeah, I think you're right about that, Christopher. So, like this, and then if R in, or not in, oh, now I'm not printing anything, so I don't know. I'm just going to open this. What? Build. Build? I can't type. Build code debug. There we go. And is it this one? Yeah. Let's have a look. All right, let me just remove all these breakpoints. And we'll add one here. All right, what do we get? Locals, no locals. How are there no locals? We got RAX, and it is okay. So we got RAX. We can use that apparently. Okay, that's cool. So that's giving us the first register that's not used. But we probably don't want to just get the available register. We also want to do we want to get the available register and then I'm thinking, do we want to update use registers here, or do we want to do it outside here, or do we want to make this like, you know, push value, and then it can either go to register or the stack and tell you which one it went to or something? I don't know. But in this case, Christopher says get register versus alloc register. Yeah, well, we're not allocating the register, so that sounds confusing, but I think I see what you mean. So now we've got a register back, let's say. Just going to break here. Let's just say we got a register back, and we're declaring a variable. We want to put into that register the value of the expression that's on the right-hand side of this variable declaration. So Christopher says, like you're allocating / reserving use of the register, and then later you free / release it. Oh yeah, that makes sense. I see what you mean. Yeah, yeah, right. So reserve register and then release register, maybe reserve and release. That could make sense. I might change this here and get available to reserve, and then if it returns false, well, you got to do something with the stack. And then maybe later we'll make another one that's just reserve space or whatever, or reserve value, and then it can call these two procedures internally, and then we don't have to do this manually. But I just want to figure out how to just declare one variable first. Okay, so got our register, we're going to put it in there. We're going to put it in this register. How do we do that? Well, for extra drama, you could do claim and abandon. Oh, man. Yeah. Yeah. Abandon has some loaded connotations. So I want to add to the string builder, move into register. No, not comma here. The value, which is. So I'm just gonna. I think that'll give me a capital RAX. That should be fine. But then the value is going to be. I don't know. And also. I'm thinking too hard about this. I mean, I'm trying to think too far ahead, but I don't know enough. That's kind of what I'm saying. I'm thinking if you had, let's say you had an assignment like this, and then you had a function like this, function call, right? Now you've got to evaluate the function call first to get the resolved expression, which is then going to be in RAX anyway. So I guess you'll be saying like, move into RAX because it's already in there, and then call add, but before call add you have to move into RCX the value 40, move into RDX the value 2, then call add, and then this is already in there, but then where does the name go? This is probably why they do SSA form first before register allocation. Yeah, I want to know what that is. I think what I should probably have done is made a different representation for the code first. Is that what this SSA is? Social Security Administration. That is not programming assembly. I don't know. Static single assignment form. All right, let's have a look at this. Oh, God. Can we make it dark? There we go. All right, let's have a look. I'll make it a bit bigger. It's a type of intermediate representation where each variable is assigned exactly once. SSA is used in most high-quality optimizing compilers for imperative languages. Oh, this makes sense. Okay. The primary usefulness is how it simultaneously simplifies and improves the results of a variety of compile optimizations by simplifying the properties of variables. For example, humans can see that the first assignment is not necessary and that the value of y being used in the third line comes from the second assignment of y. Right, yeah. So you don't need that one. Correct? The program would have to perform reaching definition analysis. Uh-huh. But if the program is in SSA form, both of these are immediate. Why are they immediate? I guess I have to figure out what SSA is exactly. Algorithms that are either embedded or strongly enhanced by the use of SSA include constant folding. Yeah. Okay, we definitely want, I think we do want to do this. We probably want to do this first. Thanks for telling me about that, Christopher. Sparse conditional, constant propagation. Okay, we don't need to worry about a lot of these optimizations yet, but this is probably what we want to look at. How the limited number of machine registers may be used for calculations. Converting ordinary code into SSA is a matter of replacing the target of each assignment with a new variable and replacing each use of a variable with the version of the variable reaching that point. For example, okay, so x is assigned a value 5, x is assigned a value x minus 3. Is x less than 3? Yes. Oh, but then which way is yes? Or does it not matter? Oh, all right. Okay, yes or no. Okay, y is assigned to value x times 2. W is assigned to value y. Y is assigned to value x minus 3. Closely related to 3-code IR as well, says Christopher. Okay, I'll have to look into that. Wait, FreeCodeIR. FreeCodeIR. I think that's how I program my assembly language. Why is that familiar? The one for my game. I did most of that work back in December, which is maybe why it's a bit fuzzy. Yeah, that's really familiar, three-code intermediate representation. Let's have a look at that. I don't know why I'd open a new window, but okay. 3 address code. Okay. Each TAC instruction has at most 3 operands and is typically a combination of assignment and a binary operator. For example, T1 is T2 plus T3. Okay, fair enough. Yeah, I think I used this. But right, okay, I see. So extracting the terms. Well, they're not just terms, but I see. Calculate one solution to the quadratic equation. This. Man, I'm not a math nerd enough to verify this right now. T1 minus. Like, where did that even come from? Oh, from b times b. Square root T4. I see. So basically breaking this up into a set of operations that can be run sequentially as binary operations. Okay. Man. Common sub-expressions. Yeah. In this form, you have simple assignments to unique names, and then you can more easily know how to propagate and reserve where to store stuff. Yeah. All right. I think I might have to do a little bit of research over the weekend then. But again, you've only read about it. You haven't done it yourself directly. Okay. That's cool. Yeah. Well, I can see that the direction I'm going is not gonna, it's not going to be the solution that we end up using because it's too inflexible, I suppose. It's brittle. Doesn't quite work. So it's going to get really complex and not handle a lot of cases, I think, if I do it this way. Yeah. Okay. All right. I think I'll do some research over the weekend, and then next week we can work on maybe IR. Because we've got, a simple parsing program that actually outputs correct code and runs, so that's cool. But to make something more complex, we probably need to do something a bit more complex. Or I could also look at Jack Crenshaw's How to Write a Compiler. Where is it? Oh, it's called Let's Build a Compiler. Why does it have to be bright white? Abdul says, gotta love the compiler difficulty curve. You do type checking, which is already pretty hard, and then you end up in compiler backend hell. Yeah. Oh yeah, it's gonna be hard. I have no doubt it's gonna be really hard. That's why there just aren't that many people doing it, I think. And maybe it's also very niche. So can't remember. This is all in Turbo Pascal, and it's in this like format from the 1980s, where this is how you write posts. like GameFAQs, if you guys are old enough to know what I'm talking about. The old tutorials for games. I didn't even skim anything of what this says. He's doing some digressions. Studied almost all the basic features of compilers and parsing. We have learned how to translate arithmetic expressions, booleans, control constructs, data declaratives, and IO statements. We have defined a language, Tiny 1.3, that embodies all these features, and we've written a rudimentary compiler that can translate them. All right. Evan asks, have you looked at Gingerbill's Titania language? It's being made to teach compiler development. Oh yeah, I forgot about that. No, I haven't actually looked at that. I haven't looked at that. Let's have a look. Based on Oberon 07. Ah, by Worth. Or Worth, I can't remember how to pronounce his name. Niklaus. Right, I didn't know that. Yeah, it's been updated as of 2 weeks ago. So it looks like he's working on it. Let's see, what have we got? I mean, I imagine it's going to be similar to what I'm doing because what I'm doing is similar to Odin, but he did say it's based on Oberon 7, which I didn't even look at. Okay. Standard operators, oh, this is a bit different. Okay. I wonder. How closely is it related to Oberon 7? Evan says it's using Rex code for the backend. Okay, I don't know what that is. What is Rex code? No, this is very small. Let's see. Okay. Well, this is just going to go over my head right now. I'm not at the level to understand all of this. Rex code is a new thing in Odin core for machine code generation. Oh, right. Okay. Yeah, I haven't been keeping up with all the updates to Odin. That's cool. Right. So, I was going to build this myself, basically this structure. I guess I don't have to. I use this. Let's have a look. Oh, right. I wanted to go to the package. Rex code x86, I guess. Or is it ARM64? No, not ARM64. AMD64. But no, x86, I guess. Okay. So they really want us to know that Brendan Punske is the author. That's cool. Maybe I'll look at that. Hey, Guild Co. It's going well. How are you? Right. High performance multi-architecture instruction encoder decoder / printer library. Gotcha. Okay, so we got x86 64 plus i386. Okay. Currently writing a compiler, but got up to a point where we can do really simple stuff like call a function and, move some numbers into the return slot. But now that we want to do something even slightly complicated, I'm running up to this, sort of running into a wall here where I'm outputting strings directly, and I should probably not be doing it this way. I probably need to generate an intermediate representation and then use that to emit the assembly itself. Yeah, I might look into this at some point. Thanks for the link, Evan. Seems pretty cool. But yeah, I'm actually just about to head off because I need to do some more research before the next stream. So I'll probably stream again on Saturday, maybe Saturday night, but it depends because my brother just randomly showed up in town, so I might see him. I mean, I already saw him, but I might see him again. Or otherwise, I'll stream on Monday. Is the compiler for some weird edge case need? No. It depends what you mean by that. I already covered it in previous streams, or earlier in this stream actually, but no, I want to test some hypotheses about writing programs, and I need to make a language to do that. So, yeah, I think that's it. I think I'm gonna call it there, guys. It's been a pretty long, well, 2.5 hours. Not that long, but yeah, I do have to go do some work, more work. Gotta get that nav mesh done. And also, there's noise in my apartment, bumping stuff, which is distracting me a lot. So, good timing. But I want to thank you guys for tuning in. In the next one, we'll try to get maybe some kind of intermediate representation going. And I'll see you there.